This is one of the previous question collected. Given question is minimize the following deterministic finite automata shown in figure. So this is the question taken from the previous question. So this is the DFA given in the following figure, which is called as a transition diagram. So this DFA consisting of A to H states. The states are named with uppercase letters A to H. And here A is initial or start state. So in the given DFA, M equal to Q sigma delta Q naught F, where write on the tuples, where Q equal to the set of states, capital A to H, A, B, C, D, E, F, G, H, and sigma equal to input alphabet. So input alphabet is 0, 1. Then Q naught is the initial state is capital A. So this is initial state. Then final state is C here. Then F equal to C, and delta is given below. So write down all these transitions. These transitions we will use during solving the minimization of problem. So delta of A on 0. Here you can see A on 0, it is going to B. Then delta of A on 1. A on input 1, it is going to state F. Next, delta of B on 0. So B on 0, it is going to state G. Then delta of B on 1. So B on 1, it is going to state C. Then delta of C on 0 equal to, from C on input 0, it is going to state A. So now the next state is A. Then delta of C on 1. C on input 1, it is going to C itself. Then delta of D on 0 equal to, from state D on input 0, yeah, it is going to C. Then delta of D on 1. From state D on input 1, yeah, it is going to state G. Then remaining states also you can write down. Next, delta of E on 0. Next, delta of E on 1. Next, delta of F on 0. Next, delta of F on 1. Next, delta of G on 0. Next, delta of G on 1. Next, delta of H on 0. Parallelly, you also do the problem. Next, delta of H of 1. Now substitute all these transitions. Now E on 0, it is going to state H. Then E on 1, it is going to state F. Next, F on 0, it is going to state C. Next, F on 1, it is going to state G. Next, G on 0, same self loop, it is going to G itself. Next, G on 1, it is going to state E. Next H on 0, it is going to state G. Next H on 1, it is going to state C. So this is delta. So now coming to our minimization problem. So minimization of Dfa. So here we will use table filling algorithm. Table filling algorithm. So first draw the table. Here the states are A to H. So you can take the combination of the pair by avoiding diagonal combinations. So in x-axis you can start with second state. So B, C, D, E, F, G, H. You can start with the second state and continue till the last state. Now in x-axis you can start with the first state, then you can remove the last state, that is H. You can continue A to G. Now A, B, C, D, E, F, G. Now you can draw the matrix. Here y-axis first state, you can connect it to x-axis first state. Like that you have to draw the matrix. Now in this matrix, you can see diagonal combinations doesn't exist. So automatically diagonal combinations are removed. Now you can see here. Now you can take pair as consider a pair as x comma y coordinate. The order. First you can take x-axis state followed by y-axis state. In a pair, let us say p comma q is equivalent to q comma p. That is, pairs are unordered. Pairs are unordered. So now this is the table. First you have to draw this table. Now you can see A to A combination we don't have. B to B combination, here this is removed. C to C, here it is removed. Diagonal combination. D to D is removed. E to E is removed. F to F is removed. Then G to G is removed. Then anyway H to H we don't have. Now in table filling algorithm, step 1, as per the algorithm, mark a pair P comma Q. When you have to mark, if and only if P belongs to a final state or Q not belongs to a final state. That is, combination of a final state, non-final state, or reverse. P is not belongs to F, then Q is belongs to F. That is, non-final state, comma final state. This is the first step. So you have to mark a pair P comma Q if and only if P is a final state and Q is not a final state. That is final state comma non-final state combination, or reverse. If P is not a final state and Q is a final state, that is non-final comma final state. Here marking can be done using the symbol into symbol. In the table, wherever the pair is going to be marked, we can use the symbol into symbol. Now take the pairs, check out which are combination of final state. So you can take x comma y coordinate format. First here you can see, first you can start with A. So A to B, A to C, A to D, A to E, A to F, A to G, A to H. So like that, take all the pairs. Now which are combination of final state, that you can see. So now consider the pairs of F comma NF or NF comma F combinations. So any of these combinations are exist, you can take. So here C is the final state. So take all the pairs combination of C with all A to G starting with. So first you can start with A, then take the first column A to B. See, both A, B are not final states. I mean, both are non-final states. Now you can take AC, A comma C combination. So the first one here you will get A comma C, where A is not belongs to final state and C belongs to final state. So therefore, so mark the pair A comma C by into symbol. So you have to mark A to C. Then next you can see A to D. So A to D both are non-final state. A to E also both are non-final state. A to F also both are non-final. A to G also both are non-final. A to H both are non-final. So here no marking is occurred other than AC. Then coming to second x-axis value B. Now you can take combination B with second column. Here you will get B to C, B to D, B to E, B to F, B to G, B to H. So from second column, you will get only B comma C combination. Here you can see where B is not belongs to F and C belongs to F. So it is combination of non-final final. So mark B comma C by into. Now you can see. So you can mark B, B to C. So remaining B to D, B to F, B to G, B to H, we can't mark because these are all both are combination of non-final states. But our condition is either final or non-final or final or non-final. Only such cases only we have to mark. Then coming to third column with the C. So with the C combination, C to D, C to F, C to G, C to H. Here you can see with column 3, all are with combination of C. Here you will get C to D, then C to E, then C to F, then C to G, then C to H. Here you can see all are combination of a final state. C is the final state. Now one state is final state means other state compulsory should be a non-final. Now here you can see D is non-final. Now it is in the form of F comma NF. Here also C is F, E is non-final state. Now C is F, F is non-final. Now C is F, G is non-final. Now C is F, H is non-final. So So mark all these pairs by into symbol. Now with combination of C, you can mark all the pairs. Now C to D, C to E, C to F, C to G, C to H. Now next state is D. D with C we don't have any combination. E with C we don't have any combination. F with C we don't have any combination. G with C we don't have any combination. So initial step, these are all the only pairs marked which are combination of final and non-final state combination. Now step 2, what you have to do. So other than final non-final combination, you can apply step 2. Mark a pair P comma Q if and only if delta of P on A comma delta of Q on A is marked for some A belongs to sigma. See this condition. So now you have to mark a pair P comma Q. When you have to mark if and only if there exists a pair by applying its transition function. So the pair, the first state is P. So you can find out the state P transition by applying delta of P comma A. Similarly, for the state Q, find its transition, that is delta of Q comma A on some input. Some A belongs to sigma. Sigma is alphabet. So at least some A. In our case, sigma equal to 0 comma 1. Either on input 0, on input 1. In any one case, if this pair is marked, that is delta of P comma A comma delta of Q comma A, then you can mark P comma Q. This can be repeated for all unmarked pairs. Now what you have to do, you can consider all unmarked pairs one by one. Then you have to find the transition combinations, either first input or second input. On any one input, if you will get marking, then you can mark your current pair. On first input, you didn't get marking combination, then go for second input. Second input also, if you didn't get marking combination, don't mark, no problem. Like that, you can repeat this process for all unmarked pairs. Now with first column, state A combination, except A to C, remaining all are unmarked. So consider all the pairs and apply this rule. Now consider all unmarked pairs, all unmarked pairs, and then apply step 2, and then apply this step 2. Now you can see first with state A combination. So A to B, A to C already marked. You can take only unmarked. A to B to A to D, then followed by A to H. So now here you will get A to B is not marked. Then second one, A to C is marked. Then you can take A to D is not marked. Then A to E is also not marked. Till last combination you can take. Then A to F, next A to G, then A to H. Now see, except A to C, remaining all are unmarked. Now you can apply this delta function on any one input. Suppose here first the inputs are 0 comma 1. I am taking A comma B on 0. This can be written as delta of A on 0 comma delta of B on 0. Now find this value. Here what you will get, the transitions we already written. So A on 0 equal to B, then B on 0 equal to G. So you will get B comma G. Now this value is B comma G. Now check out B comma G is already marked or not. So BG except BC remaining all not marked. So is not marked. Then coming to other input, on input 1, same you can apply A on 1, delta of A on 1 comma delta of B on 1. Now substitute delta of A1 and delta of B1. A1 equal to F, B1 equal to C. Now you will get F comma C. So here you will get F comma C. Now you can see in the matrix we don't have F comma C combination. This is equivalent to C comma F. Why? Because the pairs are unordered. You can interchange the order. CF, now you can see with the C combination, CF is marked already. So here you will mark A comma B. CF is already marked. So mark the pair A comma B by into. So now you can mark AB now. So here AB. So this can be marked in second step. So you can, for your understanding, I am writing the step number, but in examination you don't write. So in second step, the pair A comma B is marked. Similarly, A comma D. So parallelly, you will also start doing. So now AD on 0, here directly I will write the transitions. You can apply delta function. Now AD, so you will get B comma C. So now let us see B comma C. So BC is already marked. So now you can mark AD also. So BC is already marked. So mark A comma D. Now on input 1 you no need to find. Why? Because on one input you are getting marking. Then no need to find other input. Suppose on first input you didn't get marking, then you can go for second input. So already on first input itself we got marking combination. So then you can mark AD here. So now here A to D. So this is also in second step. Then coming to AE. So AE on input 0, you will get B comma H. Now you can check out B comma H is marked or not. See, with BH combination, this is blank, so it is not marked. So is not marked. Then you can go for other input. AE on input 1. On input 1, see A on 1, it is going to F. E on 1, also it is going to F. Here you can see F comma F. So not exist this combination. Not exist. F comma F. The diagonal combination we don't have. So here also marking not possible. On both inputs, AE is not marked. Okay, no problem. Let us keep blank only. Finally, we will check. Then coming to AF. So here AF on 0, find the transition delta of A on 0, F on 0. You will get B comma C. Now let us check the pair B comma C. Yeah, B to C is marked already. So you can mark A comma F also. So is marked already. So mark the pair A comma F. So now you can mark A comma F. So this also marked in second step. Then next pair is AG. Similarly, on AG, on first input 0, here you can find the transitions. You will get B comma G. Now let us see BG. So BG is not marked previously. So we can't mark here. Then let us go for other input. AG on input 1. So on input 1, you will get A on G1 F, then G on 1 E. FE pair we don't have, interchange. E comma F. Now see EF whether it is marked or not. So E to F till is blank. So in both cases not marked. Then coming to A to H. A to H on 0, you will get B comma G. Previous step we already got BG is not marked. Then on input 1, here you will get F comma C. We don't have FC, but we have CF interchange. Now see C to F with the final state combination all are marked. See C to F is marked here. So C to F is already marked. So mark A comma H. Now you have to mark A to H. So this also in second step. The same process we can repeat for all other pairs. Next B with D, E, F, G, H combination except BC. So now this is for state A combination, x-axis state A. Next you can take state B combination, then state B combination. Here you will get BC already marked. Remaining all you can take BD, BE, then BF, then BG, then BH. With B combination, these are all the pairs which are unmarked: BD, BE, BF, BG, BH. Now you can find out the transitions in the similar fashion. So here directly I am writing the transitions. Later you can check. So BD on 0, you will get G comma C. But GC combination we don't have, but CG we have. C is the final, G is non-final. This is already marked. So E is already marked. So mark B comma D. Now you can mark B comma D here. So BD you can mark. So this is also in second step. Then BE combination. So BE combination on 0, you will get G comma H. See, GH is not marked earlier. Now you can go for other input on 1. B on 1, you will get C comma F. So C is final, F is non-final. This is already marked. E is already marked. So mark the pair B comma E. So now we have to mark the pair B comma E. So in second step. Then the pair B comma F. So now B comma F on 0 first find out. So here you will get G comma C, but GC we don't have, but CG we have. So CG is already marked. Why? Because it is combination of final non-final. So mark the pair B comma F. Now we have to mark with into mark the pair B comma F. Next coming to B to G. So B to G on input 0, you will get both G. So this combination not exist. Then you can go for other input on 1. So BG on 1, you will get C comma E. So E is marked already. So mark the pair B comma G. Now you can mark the pair B comma G. Then last one B to H with combination of B. Now B to H on 0, you will get GG. Here this combination doesn't exist. Then coming to on 1, you will get CC. Both final. This is not possible. This combination not there. So here B to H is not marked on any input. Then coming to next state, C all are marked. Next other state, you can take state D. Now with the D combination, what are the unmarked pairs? So D to E, D to F, D to G, D to H. These are all unmarked. So now D to E, D to F, D to G, then D to H. Similarly, find the delta value. Now D to E on 0, here you will get C comma H. So final C, non-final H is marked. So mark D comma E. So now you can mark D comma E in second step. Then D to F. So D to F on 0, you will get both final states. This can't exist. Then D to F on input 1, you will get both G's non-final. This combination also doesn't exist. Next, D to G on 0, you will get C comma G. Final C, non-final G is marked already. So mark D comma G. Now mark D to G pair. So D to G. In the second step it is marked. Then D to H combination. Next D to H on 0. So again here you will get same C comma G is marked already. So mark D comma H pair. Now you have to mark D to H. Now coming to E combination. E combination we have EF, EG, EH. 3 pairs are there. Then state E. State E combination. What are the unmarked pairs we have? So we have EF, EG, then EH. These are all unmarked. Now find out your transitions. EF on 0, you will get H comma C. But HC we don't have, but CH we have. So C is final, H is non-final. E is marked. So mark the current pair E comma F. First all you can find it, later you can mark. Now EH you have to mark. Then similarly find out EG. EG on 0, you will get H comma G. HG we don't have, but GH is there. GH is not marked. Then on input 1, what you will get? F comma E. Interchange this one. Now EF also not marked. So here let us see EF. See, EF is recently marked. So here EF is recently marked. So then you can mark this also. So EF is marked. So mark EG also. Then similarly EH on 0, you will get H comma G is equal to GH. GH is not marked here. Then on input 1, you will get FC. But we have CF combination. So CF is marked earlier. So mark EH. Now here you can see with state E, all pairs are marked. With state E, all pairs are marked in this step. Then come back to F. With F, we have two combinations, FG and FH. Then state F. So we have FG and FH. Now find the transitions. FG on 0, you will get C comma G. C is final, G is non-final. This is already marked. So mark the pair, current pair A comma G. Now FH on 0, again you will get CG only. CG is already marked. So mark the pair F comma H. So with FG, FH, both pairs are marked now with F combination. Then the last combination G. G combination, the pair is GH. We have only one pair with state G. Now state G, we have the unmarked pair GH. Now GH on 0, here you will get G comma G. Here marking not possible. Both are non-final, that too this combination doesn't exist. Then on input 1, here you will get EC. EC we don't have, but CE we have. C is final, E is non-final, this is already marked. E is marked. So mark G comma H now. Now, so G comma H is marked. So this is step 2. So now you can find out still unmarked pairs. You can repeat step 2 again. So after step 2, there may be chance of getting some pairs may be marked. So with A combination A to E, with B combination, see B combination B to C, this is already marked in the first step itself. Then you can take B to D and B to H, then D to F. So now list out all unmarked pairs now in step 3. Step 3, repeat step 2 for all the remaining unmarked pairs. Unmarked pairs as obtained in step 2. Now, what are the unmarked pairs? You can write down. Therefore, the unmarked pairs are the first one. So what are the unmarked pairs? So A to E is there. First, with the combination of A, we have one unmarked pair. So that is A to E. Then second one, with the combination of B, we have BD and BH. Two pairs are there. So BD and third pair is BH. Next C combination we don't have any, but because that is final state, all are marked. Then D combination we have DF. So this is the only one. So DF is unmarked. Again apply the step 2. Now see AE on 0. Here you will get B comma H. So BH also in the list of unmarked pair. So we can't mark. On 1, you will get FF. This combination doesn't exist. So AE is marked only if BH is marked. Now let us check later. Then BD. So BD on 0, see what you will get. So here BD is already marked. We didn't mark it here. See, BD is marked in the step 2 itself. So BD we didn't mark it. So then other one is BH. So this BD is already marked in step 2. Then BH you can take. BH on 0, you will get GG. BH on 1, you will get CC. See, GG combination we never get. CC combination we never get. So BH will never mark. Why? Because BH on 0, you will get GG combination on 1 CC. So whenever BH is never marked, then AE also never marked. Why? Because AE on 0, you are getting BH. FF we didn't get. So here BH is never marked. So AE is never marked. Then BH on 0, you are getting GG. On 1 CC. So BH pair also never marked. Then finally check out DF. DF on 0, you will get CC. DF on 1, you will get GG. See, both final, this pair doesn't exist. Both non-final, GG, this pair doesn't exist. So DF also never marked. By repeating step 2, the following pairs never marked at any case. Then finally, you can stop, find out the final unmarked pairs. Unmarked pairs are, the first one is AE. First unmarked pair is AE. Second unmarked pair is BH. Then third unmarked pair is DF. So these are all unmarked pairs. Now we will call it as equivalence classes. All these pairs are called as equivalent classes. That is, you can write like this. A is equivalent to E, B is equivalent H, D is equivalent F. Now, this can be written as, by combining these two, AE. Now this can be written as BH. This can be written as DF. So these are all merged states. Merged states in DFA. Now wherever state AE occurred in DFA, you can take combination of AE only. Wherever BH occurred, you can take the combination of state BH only. Wherever DF occurred, you can take the combination of DF only. Now these are all merged, means these are all single states. So now with these states, now we have to construct the minimized Dfa. Construction of the minimized Dfa. So along with these merged states, you can take the remaining missing states also. Therefore, the states of minimized DFA are, so the first state is, let us take Q dash equal to, now with A, now our state is AE. With B, our state is BH. Now AB, next missing state is C. With D, we have DF. Now A, B, C, D, E, F. Now G is missed. Now see, these are all the states of minimized DFA. So now you can find out the transitions of all these states. So delta dash of AE on 0, delta dash of AE on input 1. Apply union rule. This is nothing but delta of A on 0 union delta of E on 0. So whatever the next states you will get, again you will take the combination. So here you will get BH only. Next AE on 1, you will get DF only. Apply the delta function by applying union rule. Then delta dash of the second state is BH on 0, you will get only single G. Delta dash of BH on 1, you will get C. We have separate state C. Next delta dash of C on 0. The same transitions in the given, so C on 0 in the given DFA, you can see C on 0, it is going to A, but we don't have separate state as A. You can take the combination state whatever. Then delta dash of C on 1, it is going to same state itself, self low. Then next state D. We don't have state D now. Now we have the combination of DF. Now DF on 0, you will get C. Then delta dash of DF on 1, you will get G only. Now finally the state G. So delta dash of G on 0. So G on 0, it is going to G itself. Then delta dash of G on 1, it is going to, actually G on 1, it is going to E, but we don't have E as separate state, but we have the combination state with E as AE. Now these are all the transitions of the minimized DFA. Now draw its diagram and table. Minimized DFA transition diagram. Similarly, you can draw its table. I will draw transition diagram here. Now here, what are the states we have? Total we have 5 states. The first one is AE. All states you can represent within square bracket. Then followed by circle. Then BH is the second state. Next we have C separately. Next we have combination D comma F is another state. Then last state is G. Total 5 states we have. Now initial state in the original DFA, initial state is A. Whatever the state combination of A, that is now initial state. In the original DFA, final state is C. Whatever the states which are combination of C, those are all final state. Here we have only single combination. Now the transition. AE on 0, the above transitions you can apply. It is going to BH. then AE on 1, it is going to DF, then BH on 0, it is going to state G, then BH on 1, it is going to state C, then C on 0, it is going to AE, then C on 1, the self loop, it is going to C itself, then DF on 0, it is going to state C, then DF on 1, it is going to state G, then G on 0, it is going to G itself, then G on 1, it is going to state AE. Now this is the minimized DFA. Minimized DFA. Now you can see in the original problem, we have the states A to H. Now AE are merged, B and H are merged, D and F are merged. So 3 states are reduced, merged with existing. So total 8 states become 3 states here. So like that we have to construct the minimized DFA.